Hello, hello. I just brought a little piece of rock from the mountain today, from Montaña Blanca, and what we saw there was obsidian lava flows and pumice deposits. And chemically, they are pretty much the same. The obsidian lava flows and the pumice, the white creamy pumice, is compositionally almost identical to the obsidian lava. And of course, the students were very intrigued by this, and they asked, how can this be? How can there be a difference here? And here's a lovely specimen, and this is obsidian, and you see it's shiny, and it's shiny and black. And on the other side, we actually see a bit of frothing. We see some vesicles, and there we see that the color changes. And let me just turn this around, and I hope this works. Yeah, so here we have some vesicle trails, and there the color changes. And this is largely because the light is reflected differently when you have vesicles with thin vesicle walls. And the concept is actually very similar to Coca-Cola or something like that. If you pour Coca-Cola into a glass, then you have the dark liquid, but the foam is actually much lighter in color. And I just bought myself a Coca-Cola to illustrate that. And here's my glass here, and I already tried it. But if I pour in Coca-Cola here, you see that the bottom part is black, but the foamy part is not. And it's actually light in color. But of course, it's all Coca-Cola. It's all compositionally the same. And once the gas has escaped and the bubbles are gone, then it goes back to the other color, because light is actually refracted and broken differently in these different parts. So I'll add a little bit more, and you can see it again. So here you have a different color again in the foamy part. And this is pretty much the same that we see down here in the obsidian. We see the dark part, and we see the foamy part, the vesicular part, that is actually making a somewhat creamy whitish color. So I hope this was useful. Thank you very much, and all the very best.